Okay, so this is 8.1, chapter 8, section 1, multiplication properties of exponents. So what I'm gonna do is give you the property, then we're gonna do some examples, and then we'll do the next property. So just so that we have a way to describe the properties, I'm gonna give you the names. The names are not as important as actually memorizing the property. So Roman numeral 1 is product of powers. Product of powers. All right, so product of powers is where you are going to multiply different exponents together. So there's a couple things, though, that you have to watch for. First one is, in order to multiply, you must have the same base. You can't have a base x and a base y. So what do I mean by that? Let's say you can multiply x times x and get x squared. That will work because they're both base x. If you do x times y, though, the bases are different, so you can't really combine those. You just push them together into xy. So yeah, x's with x's, y's with y's. And this is just in general, is that all numbers or variables have a 1 for a power. It's invisible, but it's there. Everything is to the power of 1. So if you have the number 5, for example, there is an invisible power of 1 on the 5 that we just don't write unless we need to do math with it. Okay, so what is the actual property? The property is keep the base, add the exponents. Keep the base, add the exponents. So the formula for this is a to the power of m times a to the power of n. They are both base a, so you keep the same base, so you keep the a, and then you add the exponents m plus n. And that is how you simplify when they have the same base. All right, so now we're going to do some examples. We're going to start easy and go more complicated. So let's start easy. A squared times a cubed. Both are a base a, so you keep the base a, add the powers, 2 plus 3, which is a to the 5th. All right, let's do another example. 4 cubed times 4. All right, that little 4 has an invisible 1 in the exponent position. So when you multiply, keep the base, which is 4, add the exponents, 3 plus 1, so it's 4 to the 4th. Now, numbers you always multiply out. 4 to the 4th is 4 times 4 times 4 times 4. The big number tells you what the base is. The little tells you how many of them you multiply together. So this means there's 4 4s, which is 256. So always multiply numbers out. All right, let's go a little bit more challenging. Example 3. We're going to go -2 squared times x cubed. This is one of the trickiest thing about exponents is if the number does not have parentheses around it, like this 2, then what it actually is a -1 times a 2 squared, and that negative is its own number out in the front. Now the x's, on the other hand, both have a base x. That one has an invisible 1, so you're going to keep the base x, add the powers, 1 plus 3. So exponents go first. 2 times 2 is 4. So I have -1 times 4. And then again, exponents first. 3 plus 1 is 4. X to the 4th. So we get -4 x to the 4th. So because that negative is not in parentheses, it's not being raised to the power of 2. So what does it look like when it is being raised to the power of 2? That's example 4. It would have to be a negative 2 in parentheses with the 2 on the outside. So that one, yeah, the negative and the 2 are being squared. So you're going to have negative 2 times negative 2, since there's 2 of them, times, okay, now the x's, the single x has an invisible 1. So x to the power of 1 plus 3. Negative 2 times negative 2 is positive 4 x to the 4th. So really important that you keep those two straight. Which one is which? All right, last example, and then we're going to move to the next property. Example 5. We're going to multiply x cubed y times x times xy to the 4th. So on your worksheet or on your paper, you're going to want to go through and put the invisible ones in. So y to the 1, x to the 1, x to the 1. That way you can actually see them. Now we can multiply the x's together, keep the base, add the powers. So I have a power of 3 plus a power of 1 plus a power of 1. Those are all my x's. And now y, base y, keep the base, add the powers. I have a power of 1 and a 4. 1 plus 4. So 3 plus 1 is 5, and then I have y to the 5th. So x to the 5th, y to the 5th. Any questions about product of powers rule? All right, this is multiplying powers. Okay, Roman numeral 2, we're going to do power of a power. Power of a power. All right, so this property says keep the base, multiply the exponents. Keep the base, multiply the exponents. So this one is if you have something like a to the power of m, the whole thing is in parentheses and it's raised to the power of n. That's why it's called power of a power, because you have a power on the inside raised to a power on the outside. So using the property, you keep the base a and you multiply m times n. And that is a to the mn. One of the tricks I use is if I can draw a circle around it, it's multiplied. If you can draw a circle around the powers, then it's multiplication, not addition. All right, let's do an example. 4 cubed quantity squared. So I have a power on the inside raised to a power. So power to a power rule. Keep the base, which is 4. Multiply the powers, so 3 times 2. 3 times 2 is 6. So 4 to the 6th, which is 6 4s being multiplied together. 1, 2, 3, 4, 5, 6. The power tells you how many get multiplied together, and that is 4,096. Okay, let's do another example. A bracket, a parentheses, an x, a parentheses cubed, a bracket squared, times x. Okay, this one has a lot going on. You've got a power to a power, but you're also multiplying the x's. So how do you know what to do first and what to do second? Okay, so we're going to look at order of operations. So order of operations, you start with the grouping symbols, the parentheses and what have you. You go inside to out. Okay, so that helps you know you need to do inside before you go out to that other x. And then you do the exponents. Now here's where your properties start to come in. Your exponents is going to be your power to a power rule. That comes number 2 is power to a power rule. Step 3 is multiply or divide. Well, multiplying or dividing is product of powers, which is the one all the way up to the top. That would be the third thing you would do. And then the last thing you would do would be add or subtract, which we will get into later. Okay, so using this order of operations, we're going to go inside the brackets. Well, inside the brackets, I have an x to the power of 1 cubed, which is x to the 1 times 3, which is 3. Now we don't need parentheses. Okay, so we've done grouping symbols. There's nothing else to do inside the brackets. Now we're going to do the exponent rule. This is going to be your power to a power. Keep the base x, multiply the power. 3 times 2 is 6. Now that we've done the power to a power, which is exponents, now we're going to multiply. X is to the power of 1. When you multiply, keep the base. Add the exponents. 6 plus 1 is 7. So x to the 7th. So grouping symbols, exponent, so power to a power, then multiply. Just following your order of operations. Okay, third power and last one I'm going to show you today. So Roman numeral 3. This one's pretty easy. It's power of a product. Product means multiply. All right, so the property for power of a product is you distribute the exponent and multiply the powers. Distribute the exponent and multiply the powers. So this is one that fits the situation where, let's say you've got a to the m times b. So you have more than one thing in parentheses raised to the power of n. Okay, that little b, of course, has an invisible 1. So for power of a product, you're going to distribute the exponent and then multiply. So you're going to distribute the n to the powers. So that gives you a to the m times n, b to the 1 times n. So we distributed the exponent. And now it's just power to a power rule. So multiply the powers. So I have a to the mn, b to the n. That is your property. All right, let's do an example. I'm going to go 2x cubed quantity squared. All right, so 2 is to the power of 1. It's invisible, but it's there. So you're going to distribute the 2 on the outside to the powers. So it's 2 to the 1 times 2, x to the 3 times 2. So distribute the exponent and now multiply. I get 2 squared, x to the 6. Now remember, you never leave numbers in power form. 2 times 2 is 4. X to the 6, that would be your answer. Okay, let's do another one. 4y z squared cubed. Okay, so the 4 has a power. The y has a power. They're just invisible ones. So you're going to distribute the 3. That gives you 4 to the 1 times 3, y to the 1 times 3, z to the 2 times 3. So we distributed the power. Now we multiply. 1 times 3 is 3, so 4 cubed. 1 times 3 is 3, y cubed. 2 times 3 is 6, z to the 6th. Last thing you do is multiply out. 4 times 4 times 4 is 64, y cubed, z to the 6th. Okay, so those are the 3 powers. Now we're going to go over what are the rules of simplifying, because you need to know when you're done simplifying. And a lot of these I've already talked about, but we're going to write them down so you have them somewhere to refer to. So first thing, numbers are multiplied out. So you're going to use the number 4, not 2 squared. So numbers are multiplied out. Okay, second rule of simplifying. Powers are combined. Powers are combined. So you would use an x cubed, not x squared times x. You would have to multiply them. You can't leave them next to each other like that. All right, third rule of simplifying. When you're done, there can be no parentheses. So you can have x squared, y squared, but not xy in parentheses squared. You have to get rid of the parentheses. It cannot be in your final answer. Now, this fourth one, I bet you already know, because it's a lot of what we do with regular simplifying. There can be no double negatives. No double negatives. So you can have a negative 2 squared x, but not a negative 2 squared x. So if you've got a negative in with the 2 and a negative out in the front, you've got to simplify that. And keep going, because you can't leave the number that way. All right, and the last one, this one will make sense later when we do this property. You can have no negative exponents. Not in your final answer. So you'd have to have x squared, not 1 over x to the negative 2. All right, so the last 2 things I'm going to show you are properties that supposedly we already learned, but we're going to review them. So if you have an x to the power of 0, anything to the power of 0 is always 1. So 2 to the power of 0 is 1. Even something really complicated like 2y cubed, if that's in parentheses to the power of 0, it's still 1. So that's the first thing I wanted to make sure you knew, and I will show you why this is the truth when we get to division. It doesn't make much sense until you can do division, and then I can show you why this is the case. Okay, and then the last one, just a reminder, negative 2 squared is not the same as negative 2 quantity squared. If the negative 2 is in parentheses, when you square it, it's negative 2 times negative 2. And the negative is to the power of 2, which is 4. If the negative is not in parentheses, this is a negative 1 times a 2 squared. So the negative 1 is parked out front, and then you have 2 positive 2's that are multiplied together, which gives you a negative 4. So it gives you a different number. So just keep aware of that one in particular because that will come up.